There's really not a lot to the assembly for this project, so let's go to File, New, and we'll pull up the assembly millimeter. And really shouldn't matter, but we'll bring in the base, let it go ahead and go origin to origin, and then insert component, existing part in assembly. Oh, that was right there, so I could just do a hex key, or hex screw. Alright, so this is going to be concentric. And then we really can't see the depth or the intersection, so this would be a good place to expand out the feature tree. And the little greater than, less than symbol at the top is going to allow me to put the base into transparency. And then if we bring this down, I want to see where those are going to line up. Now they really aren't wide enough for the M6 being 5 millimeters wide. So unless there is a modification to that screw, it's pretty much just going to go in and kind of deform the edges. You get somebody torque happy like me, it's going to push it and kind of mess up those intersections. So we can kind of see where that lines up. There's a little bit of a gap. And again, we really don't know what this is doing, so there's not a lot of specification that we can do. So if I were to set that to a distance, looks like 1 millimeter would work okay, and that's pretty much it on the assembly. So where the toolbox comes in is we need to activate it, so I can add in now, or we can go up to the add-ins and do the pull down and activate the toolbox, but add in now is usually about the easiest. Expand that out, we'll go ANSI inch, and apparently I haven't turned off all of the specifications yet, so we'll do that as a separate video. But I want to do bolts and screws, a hex head. Oh, and I forgot to check, I'm in ANSI inch, we need to be ANSI metric. It's pretty much what's going to be most available. Hex head, and then we'll rotate over to where we can see where this is going to go through the through into the body. So just a standard B18 hex, and we'll line it up, and it should recognize that, well, it got close. M8 doesn't always pick the best one, and it didn't tell us how. Oh yeah, it did. M6 by 10. So as long as we're close, thread length of 18. Wow, that's an interesting. So either I picked the wrong one. 30, 35. Wow. All right, so if I just X out of that, let's see what else we have available. So maybe a formed hex screw. And no matching size for this component, even though it's a whole wizard item, showing it as a washer face with a length of 10. All right, so close enough. If I need something that I was going to order, then we'd probably go out to a website like McMaster. And since it's still in the insert components, it's going to keep inserting those screws until I hit the X or accept. All right, so distance-wise, don't know if those, again, if those are just plugs. If we run the 10 millimeter all the way in, it will seat, but there's no relief, and the slot would have to be at least 6 millimeters wide for it not to do any serious damage. So this is kind of one of those iterative processes of, you get this far into the design, then that's a choice that you can make. Is this doing what you want it to do, or is something else going on? So if I go to the right plane and we set a distance, and right now we're at 21, so let's see what 20 looks like. and right click to accept. So 20 is right there at grabbing those edges. So we'll do 20 on the other one as well. And distance and 20 and accept. All right. So if you don't have, let's see, I need to pull in a browser window. And I'm going to go ahead and have it go out to mcmaster.com. It's kind of one of the quick easy. There are certainly others. And we want to find screws and bolts and hex head screws. And we're looking, don't necessarily need the high strength, but we go ahead and filter for metric. And 18.8 is pretty much a standard type screw. So M6 by 10, I come down to the 10 millimeter length. Box of 100s, $22. Go to the product detail, and then we can download the 3D solid. All right, and this is going to come in with those cut threads. And again, there are some advantages and disadvantages. Well, just like on our configuration here. Let's go ahead and suppress. And I need to go find that item in my downloads. And we'll put it over, and I'll just, let's see, cut it out. Get to my assignments. Paste it, and then we can insert. Component, existing, browse. All right, so it's going to come in with the part number, and on their end, the reason they're providing all of this to you is that chances are you will buy it from them. So let's see if we can find a cylinder or something that is mostly round that we can be concentric to. And it went the wrong way, so we need to reverse the mate alignment. So right click, flip mate alignment, and while we're here we'll go ahead and lock the rotation. And then it's pretty much going to be the same thing with the right plane, and a distance is going to be the easiest. Let's do it as a tangent. So if I go with the tangency, say I get out my my breaker bar and I run this thing in, that is how much we're either going to damage the screw or damage the other part. Now I mentioned in the description that unless this is a modified part, we're not going to detail it. We're just going to list it in the bill of materials, and it's going to be a purchased part. But if I was going to set this up and turn this back to a 5 millimeter by 5 millimeter deep so that it could insert in and lock down on that face, then I would need a detailed drawing for that part. So you can see the difference in the symbols. This is a individual component, individual part, where these are toolbox have the toolbox symbols. So let's see if that one's mostly a circle, so let's see if it will work. And we'll go concentric. It gets close. I either didn't wait long enough or it didn't pick up to flip the mate alignment. And again, we can go with, say, a tangency. All right, so those are kind of the options that you want to work with. Again, keeping the screws or having a screw library if we need to download. I want to bring the hex key back from the swept cut to the default. And if we were going to make a configuration here, just like we did in the part, let's go ahead and save this. And this looks like some kind of valve to me, so I'm just going to give it a name. So if we wanted to make that a configuration for the threads, and doesn't matter which ones. Okay, we'll get that in there with the threads. Then we would go back and we can pick for the, let's go with the thread feature. And then realizing that I haven't put the thread feature into this one, we could go back and hide. Well, probably going to need the base since that's where I'm putting the geometry. And we have this in context editing. So if I edit the part and this goes to blue, I'm editing this part in the context of the assembly, and I want to be careful because this has the advantage and the disadvantage of being able to relate to the other items, to the other components. So if I don't want those external relations, then I either need to hide it or just open up the part and not go through that process. So let's see, S key under the pull down, we can pull up the thread and the warning, and the thread location will be on the edge, and get the tooltip. Optional start location. Go ahead and let it start there. The blind in condition. Let's see, what did I do with the part? So it's 28 to the base, and it looks like probably, well, they're going to call it all the way to that that edge. So we'll see what we get up to selection. Now on in the real world, in the real life, we're not going to be able to run these threads all the way down. So let's see, if we offset it, we had 2 millimeters, and if I reverse that, that brings it down. But a tap, not going to be able to get in there. A thread forming tool or a thread insert tool on a lathe would be able to get really close to that, but unless there's a relief there, we're really not going to get that level of geometry. So we're now switching over to, nope, not the inch, and always switches the inch to the odd 80s and then takes forever to calculate. So let's go with the metric tap, and that's 80 threads per inch on a 20 millimeter. So let's go with the M20 by 2. Minor diameter of 18, pitch of 2. It is a cut thread, and it's kind of showing it there that it will terminate. And we can go ahead and accept it and see what it looks like. All right, so the other question is, as far as reality is, it terminates at that point. So if I was 3D printing this, I would not get a complete thread. So I want to edit the feature. And then there's always going to be, with a 3D print, a certain amount of scaling. If the tolerances on the threads usually have to reduce somewhere in the neighborhood of 0.25 to 0.3 millimeters, so that have extra clearance for the 3D print, the variation in the 3D print. So we're offsetting this. I'm going to go ahead and offset it 2 millimeters. Went the wrong way. So all this is going to do is make sure that thread fully engages at the top of the bore. All right, so we accept and get out of the thread. And now, since I did not create a configuration for this, it's pretty much in there. And the hole wizard should have produced a cosmetic thread. So let's check. Oh, I made it a cut revolve, so I didn't even put a cosmetic thread in there. So I got some catching up to do. All right, so the issue here is going to be that even if I rotate this, those threads are going to kind of line up wherever they line up. It's not really something that is going to be super consistent. if we started at 0 and we end at 0, then they should line up, but it's not really a guarantee. So if I were to take the front plane of the hex screw and make it parallel, parallel is preferable, and you can kind of see that mismatch, the transparency to the solid. So let's go back. Oh, that was parallel to the front plane, so I need to be in the hex screw, mate, and let's see if we reverse that. Flip the mate alignment 180 degrees. Those line up pretty close. So it looks good. Maybe there's even some building there, and if we did manage to get the threads all the way to the bottom, such as a 3D print, there would be plenty of clearance there. So I want to go back and make the corrections. Oh, that was to the base. So let's just go that way. And we'll add a configuration since this is already in place. This is the thread feature configuration. I go back to the default. I suppress the thread. And then pretty much need to get to that inside edge. Insert to the annotations into our cosmetic thread. It found the M22, but we'll go to the M20 by 2. And looking at the depth, it's showing it as up to next, but realistically we need that to be about 18. Okay, maybe 20. Alright, so we take a look at the result. Does the result look realistic? And then we go ahead and accept it, and then we can verify it once we're back in the assembly to the parts. Alright, so in this configuration we're in the threaded side, and I need the base to also show the threads now, so I'm just working through the logic of this one and that one. Right, and then in the default we'll go back, and I'm not making these suppressions out of the part. I'm changing these or verifying that they're correct in the the configurations within the part are selected correctly. So all I did was make sure that the parallel mate was not active. It was suppressed in the default, and then we can take a look, and 20 is going to be a little bit too shallow. So back into the base, probably going to be on the revolve. And we had a total of 28, so maybe we'll go 24 and have something realistic. So as a general rule, I would say plan on the threads, the thread depth that you set as being a min condition, that if the machinist can make it a little deeper, we don't know what this is intersecting, what the specification is, but if your machinist can make it a little deeper and have that extra, then you're sure that you can get to that stage. Ensuring that this gap, well, that's pretty much what these side screws should be doing, is once you get it into position, then you lock it in place. So we kind of have to go through that process as well. Didn't need to do that one. All right, so one more introduction is that we can do for the part. We could go in and add this in the assembly, but I would like to look at the interior, so like a section view of the assembly. So if I pick a cut, actually let's just go ahead and open up the sketch, and it can be on the bottom or the top. So a new sketch and align, and we'll go from quadrant to quadrant. And it's warning me that I've done an assembly sketch, which is not going to generate features in the part specifically. And in the assembly feature, we're going to do an extruded cut, and it's going to be through all. Okay, so that shows me the interior. And not sure why that went. Feature could not be created. So probably it switched to through all both and does not, since there's nothing on that side, it got lost. So if I'd put it on the top, through all both would have been okay. So let's go ahead and add another configuration. So this is going to be the assembly section. And then this is just a way that if I wanted it to cut both of these, that I would be able to manage that. In the body selection, if I wanted to show the full thread, I could remove the hex screw out of that mix and see it as the intersection between those parts that I couldn't really do out of the drawing. So if I go back to the default, and that is still shown, then we're going to manage the suppression state, save it, save all. And in this group, we'll go ahead and add our exploded view. Oh, I guess I did not go back and whichever screws you have available. Well, let's go ahead and get this started. So we'll go ahead and bring that out. Came out 73, so we'll make it a nice even 75 and done and accept. And I'll use the toolbox, so I'm going to go ahead and suppress those and unsuppress those. And then when we go back to get into our exploded view, we'll right click, edit the feature, and then now we're picking the hardware, and it'll come out some distance. 39 seems a little bit much, so maybe 25, and done. And then the last one, and just to stay consistent, 25 and done. Okay, so we have our exploded view, and make sure that that gets saved. Oh, I guess I did not name this, so the last one you will want to watch out for is this went to the tool library. So, oh, that was the valve. So no, I don't want to save those back. That might be a version issue. So since I don't have those there, we'll double click, go check on the threads, and those aren't being shown. So we'll have the alternative. Make sure those chosen to save read only. Do you want to continue? No. Well, I still need to save all. So yes, and then just cancel. Oh, I guess not. All right, so let's just check the configurations. The assembly section, they're shown now. They are not participating. They were not active when I made the pick, and that's still in transparency. It probably won't bring the transparency into the drawing, but I guess we'll see in a minute. Okay, so let's make our drawing from the assembly landscape, and we'll see which one it goes into. So the current is handy, and that it is the assembly section, so that one's for reference. And then we can go back into the view palette, and if I drag in just a regular isometric, so the current could be off a little bit and it would still find that it just happened to be in the isometric, but if that was rotated a little bit, it would also pick it up. So if I go to the default and show the default in its exploded state, then we have that one available, and notice the alignment didn't really intend that, but we got it anyway. So if that's picked or we see that that line, then we're going to get it almost like it's being projected. And then let's bring in one more. So the isometric again, So apparently that view was selected because now I'm not seeing the line, and this one moves independently. So we can talk a little bit about, let's see what this is going to look like if I go with the hidden lines. So very busy. And we'll tuck that one kind of out of the way and insert our balloons. Auto balloon, we'll let it stay with the surround, and OK. And don't really like the position of that arrow, so I'm going to move it over there. 2 looks okay, but I can't really tell what 2 is pointed to, so again, we'll clean that up just a little bit. 3 looks all right. And we're going to go to the bill of materials, tables, bill of materials. Standard, well, we're still going to be back to the default locations. I saved mine in my system files, so one of these days I got to point that so I don't have to keep navigating to it. Point that to the correct location. And just like in Excel, if we double click, let's see, I guess not, oh, there it goes. If we double click, it will expand out to where that's on one line, kind of cleans it up a little bit. All right, so the notation on the screw threads can be a little bit strange. And so let's see what this view. If I were to put it over here, and why don't we go with a top view, and I'll put that back into the default and accept it. Nope. Default, accept. And then under the drawing, if we go to a section view and I place the section view, and we get the section scope. So direction, excluding the fasteners, would ignore the. So we kind of get that, which is that, but it's not as visual, the intersections and the geometry. So again, be aware of what those are and what they're doing. And then we'll go ahead with our sheet and insert drawing view model, and we'll just call that my old habits. And I want to create multiple in the isometric, and we'll go ahead and accept. And then I want to, let's see how that's gonna go. We'll rotate the view 90 degrees and apply. All right, so that didn't really do what I want. So I'm gonna go back to 0 and apply. Yes, and if I want to end up doing this as a section view, because one of our drawing rules is trying to make this clear, if I set that to the top, the isometric stayed and the cosmetic thread stayed, so maybe we'll switch that one over to hidden lines visible. All right, so in our section view, kind of like pretty much same thing we did with the assembly, section view, except this time it's going to be vertical, and I'll drag it off to the side, and that looks okay. Those B's look really close, so if I can grab onto that, I can pull those out just a little bit. So I'm not sure which circle or which it aligned to, but that gets it pretty close. When I make these drawings, I usually reduce that text just a little bit, not quite as large. All right, and then the next sheet, we'll bring in the hex screw. So let's go to the view palette on this one. And the hex screw. And it updates, and I don't really need a section view. There's no internal geometry here, so If we were to bring these in, probably would go with the front and then the projected. And even though they all look pretty much the same, we're back to that. I would like to take advantage of the rotation. So if I rotate this over, and since I'm not doing the section view on this one, we can get those in place. 1 to 2 looks a little bit small, so we'll adjust that to 1 to 1. Now that's a little bigger maybe than I would like the isometric, but it's not going to hurt anything. And then dimensioning and pulling that off of the thread feature, yeah, no thanks. We'll go back to the default. All right, much simpler to view, much simpler to see. You can actually grab that geometry to start dimensioning. All right, so we'll go to the dimensions, and I'll start pulling out the sizes. I don't know what this will pick, since it is a revolve, but it has all of the geometry in it, so spot face, and we're in inches, so it is defaulting back to the inch dimensions. So 0.55 by 3.05 deep to that first level. So if we want to verify those, let's see where that goes to. Oh, I'm still in the hole callout, so that's not going to work. We need to go to our dimensions. All right, so the 3.05, nope. Oh, that's the 2.89. It did not find the thread callout, so and I picked the exact same thing, so an escape, and there's the 3.05, and then to the step would be the 1.79. And if we wanted to, we can try the smart dimension and see about grabbing the cosmetic threads. It did not turn off the select, so let's go back into, we are in the base. We'll go find that cosmetic thread, edit it, and thread class is fine, but I really don't need to show the type. And while we're doing that, pretty much, let's see, we're still in the thread features. Let's go back to, there we go. So we have to look for it. And we'll turn off the show type there as well and save it. Back to our valve drawing. And then when that updates, it'll be a little cleaner. The class for a metric thread, not really 2B. It's going to be typically an H6. So, those are always kind of interesting. If I want to leave those, one of these has to have priority. So if I want to leave those dimensions, I'm going to go back and pick up the parentheses for that group. All right, and then let's see, we don't quite see the one on this side. So that's kind of, and we'll have to maybe pull that over, and we'll just end up with another projected view. So we have the other side. Okay, so one higher, one lower. And let's see, back into the annotations, the whole call out, 0.2 through, M6, 2 through, M6. And we'll kind of see in the isometric view where those come into play. So the combination of those makes it a little more readable. Let's see if we can find a better spot for that one. Okay, and then these end up being opposite of each other, so which one am I looking at now? So we went that way, we went that way. Well, now I got to fold this up. If we're looking at that side, let's flip the direction, see. Well, that gives me the one I was looking for as far as the depth, but visually folding those up is a little bit different. So we're not going to be able to see that one and that one at the same time. All right, so I'll have to review that one. I know I've gone in through the sequence. So I don't know if it's going to be worthwhile to try and drag that. No, probably not. All right, so call out. All right, so the BB shows the direction, which reverses it. I would rather it be same as when we fold it up, but for our purposes now, that gets enough of a start that I'll review it on the next iteration. All right, so from the machining standpoint, the dimensions that they gave us, not so user-friendly. So we can just go ahead and give these. Now with the chain dimensions, if I were to do these individually, there would be a stack up of tolerances. As going to individual geometry, we can have the tolerances at each of those stages, at each of those levels. All right, and then for the depth, we want to pick those guys. And then that pulls up the diameter, but that really needs to have a 2 times, so if we expand that out, oh, and I forgot my standard now if that goes first or last. All right, so we'll have to go back and visualize that. All right, so the 0.79, and then we can do the 0.25 across the flats, or the 25 millimeters across flat, 0.98. And the last will be the chamfer. All right, and as mentioned, the purchase parts for the screws we're not real concerned with. And then making the next pass, we would start looking at the spacing and the layout. What looks good, what's going to give us our best geometry, and then if I want to put some reference dimensions, we could go with the 5 millimeters. Let's see, that's going to be a reference dimension, so 2 times. And that doesn't look right, but I will come back and fix it. All right, so we've got geometry, we've got our assembly. We can go ahead and save these, and some combination of our views is going to give us enough detail to make these parts.